The next topic is steam distribution system. So in this steam distribution system, we have to take care of its distribution lines, its pipe sizing, monitoring and checking steam traps, etc. So first of all, the shutting off excess distribution lines. Actually, due to installation and the steam demands, which are continuously changing, there may be few distribution lines which are underutilized, and so they result in the extra heat losses. So it is good and great idea to shut off these distribution lines because they are just enhancing the cost as well as the losses. Next is the proper pipe sizing. So here we would like to emphasize that if the steam requirement is more, then we can use the bigger size pipes for steam. Otherwise, it is recommended to have the small size of the pipe. So what are the advantages of the small pipe? If the pipe is small and if the steam is projected, especially in the thermal power plants, so it is falling on the blades of the turbines and giving the large kinetic energy. But if the pipe size is more, so then for the same pressure, the velocity or the kinetic energy which is imparted is less. But if the pipe size is too small, then it may sometimes may not sustain the pressure and may burst. And also it may lead to erosion because of the chemical depositions or corrosion if it is metallic pipes, iron pipes, etc. So that is to be taken care of. Next is the insulated related measures. So this is the big problem which is associated with the steam losses, that if the temperature or the energy which is associated with the steam is not passed on, then it means that it is being lost to the surroundings or to the vicinity of those areas which is undesired. Okay, for example, if this steam in the thermal powers are falling in the blade, then it is fine. But if it is lost to the surroundings due to insulation failure, then it is a loss. So that is to be taken care of. And those hot water lines and steam lines and condensate lines, it has the payback period of approximately 1 year each. So it is good to invest on this because this insulation energy losses or thermal losses is tuned to 90%. So it is a big portion. Next is the checking and monitoring the steam traps. First of all, we should know what this steam traps is. It is the device which is used to condensate. It is used to discharge the condensate and the non-condensable gases. Okay. So both discharge of condensates, which may be semi-solid or semi-liquid, you can say, and also these non-condensable gases. It is used to discharge those. Okay, you can say that these are unwanted as far as steam is concerned, so it should be discharged regularly. For that to happen, the steam trap should be of good quality, and if it is not maintained properly, then it may lead to 15 to 30% of the malfunctioning or the losses. So its repair and replacement should be done because it has the good energy saving, as well as the payback time is also less, 0.4 years. That is good. Thermostatic steam traps. So this is the modern thermostatic element which is associated with these steam traps. Next is the shutting off steam traps. If the steam traps are shut when they are not required or not in use, then it again helps in saving the energy, and also it has the payback period of 0.2 years. Next is the reduction of the distribution pipe leaks. So pipe leaks should be monitored very often. Okay, because if any steam is being leaked, first is the insulation. In the how it is different from the insulation. In the insulation, there will be heat loss, but there will be no loss of the steam directly. That thermal losses will be due to the Newton law of cooling. But if the steam is directly leaked due to any hole or leak, then it is a problem for us. Okay, so that is to be checked. Next is the recovery of the flash steam. So this when a steam trap purges condensate from the pressurized steam distribution to ambient pressure, a flash steam is produced, and it contains 10 to 40% of the energy content. Okay, so this is also very good. And heat exchangers are used to trap this heat, and it can be used for the space heating or the feed water preheating. It can be used to raise the temperature of the water, which is later stage boiled or used for producing the steam. Next is the pre-screen coal. So what is this pre-screen coal? In some textile plants, especially in China and a few other countries, this coal-fired boiler is used, and it uses the stock change, which result in the leakage, or you can say that the small size coal pass through it without being gone through the combustion process. So it is the waste. So to avoid this, the spiral coal screen technology is used so that these lost coals are not there. Okay. Again, if this technology is used, it has the payback period of say 5 months. So this is all about the steam system. Now it is the energy efficiency improvement opportunities in the process heating system. So the ASME group, which is the American body, so it has done some assessment for the process heating, that process heating systems that are defined as a group or a set of the combination of the heating equipment used for heating materials in the production of goods in an industrial plants. Okay, so whenever there is the production of goods in the industrial plants, so some melting process is there, rolling process is there, which may require heat. So the equipments which are used for those heating systems, you can say in the rubber industries or the steel manufacturing industries, which require a lot of heat, it can be used. So here the energy of efficiency opportunities comes under few categories. For example, heat generation opportunities by controlling the air to fuel ratio. Next is the preheating the combustion air. Okay, it is well known that if the air is helpful in combustion. Okay, but if the temperature of the air is above the ambient temperature, it will assist more. And also the oxygen content in the air also, if it is more, it will add more to the combustion. Okay, next is the heat transfer opportunities. So heat transfer will be more if there are good and advanced burners with controlling system. And next is the heat containment opportunities. So as we have just discussed in the previous topic also, that there is a big problem of insulation, that lot of heat gets lost due to the, according to Newton law of cooling from the walls or the pipes. So the boilers should be such that this is minimum. As we have discussed in the previous topics also, that suiting we have discussed, that there a layer of the carbon black is deposited, so which can be removed using mechanical and chemical process. Next is the pressure controlling also helps, and maintaining the door and tube seals, as we have discussed in the fan system also and the steam system also. So whenever there are more joints, there is more possibility of leakage, whether it is pressure system, fan system, or water system, steam system. So that is to be safeguarded. Next is the reduce the cooling of the internal parts, reduce the radiation of heat losses, as the heat losses can be through conduction, convection, and radiation. So all are to be safeguarded. So after the heating is done, then the heat recovery opportunities should be also there, that the combustion air preheating. Whenever the required steam is being produced, then the system does not shut down automatically or cool down automatically. It takes time. So ideally, we should adopt such technologies or such methods so that we can trap those heat before the system is cooled down. That trapping of heat can be through air, hot air system, or the steam system, or the hot water system, whatever it may be, condensate system, flue gases which are going out in the atmosphere. But before going to the atmosphere, we should trap its heat so that it can be used for the space heating or preheating of the water. So these are the heat recovery absorb opportunities. So it should be taken care of. Next is the specific energy efficiency opportunities in the selected industrial sectors. So energy guide for different industries are provided by different countries. In different industries which are, for which the energy star guidelines are there, are the beverages industry, cement industries, food processing, glass industry, etc., motor vehicle, petrochemical, etc. So using this energy efficiency improvement opportunities in different industrial sectors, the best available techniques are sorted out or chalked out, so that the best in the industries are carried out for the best results, and for that the BAT reference or BREF document is referred.